Welcome to this web lecture on linear programming, soft and hard constraints. I'm going to walk you through what soft and hard constraints are and how we're going to model them. So for this, we're going to use the same example that we've seen in previous web lectures as well, which is the example of a barge that can transport sand and coal. For sand, the barge operator receives 100 euros per ton, and for coal, 150 euros per ton. The total capacity of this barge is restricted. The amount of coal that is available is also restricted. And we also know that we have to turn around this barge, which means we have to load it in 2.5 hours. So now we tweak this example a little bit. Now we're no longer saying, okay, you have to turn this around in 2.5 hours, but we're saying you should turn this over in 2.5 hours. So what does this look like? The first thing we could do is we could test this problem for different sensible values of a turnover time. So how could this look like? We could use this graph and we could plot the turnover time on the x-axis and the objective value on the y-axis. The barge should be turned over in 2.5 hours. How can we model this? So the first thing that we can do is we can test the problem for different sensible values of turnover time. And this is exactly what we're doing here. So we're plotting the turnover time on the x-axis versus the objective value. And what we're seeing is that the objective value increases, but we also see that it actually flips twice. And the question is what actually happens here. So this is something that I would like you to look into is please explain what happened here at these two blue cycles. So looking into how the turnover time and the objective value relate is one first thing. So we've seen one way how we can tackle this should be. So we can plot one constraint against the objective function value, and we can see how much we would gain if we would increase some threshold a little bit. Another way that we can tackle this should be is we can add a penalty for increased turnover time. So we can say, for instance, yes, I'm willing to pay 1,000 euros to have 3 hours in Antwerp instead of 2.5 hours, because this is going to increase my revenue. This is a so-called soft constraint since we're paying for some violation. The constraints that we looked at so far are so-called hard constraints, so because there's no payment involved, but also no negotiation power. So quickly, let's look into how we're modeling this. We're also going to use the recipe for formulations, which means identifying sets and parameters, introducing decision variables, formulating constraints, and formulating the objective function. So since we're only changing a small bit, we're going to just reuse the formulation that we've seen in the previous web lecture. So we have sets, which is the type of commodity, so for instance, coal and sand. We have parameters such as revenue, capacity, available material, loading time, and turnover time. And we're just going to tweak the parameters a little bit. So now we don't have T as in the turnover time, but T becomes the unrestricted turnover time, which means this is the time for which we don't have to pay extra. Secondly, we're going to add a penalty for slower turnover P. So if it's going to take us 1 hour longer, we're going to pay 2,000 euros, for instance. But if we only take 30 minutes longer, then we're only going to pay 1,000 euros extra. This we, of course, then also have to reflect in the variables. So in addition to the amount shipped per commodity, we need a second variable, which we call delta, which gives us the turnover time increase. So this, for instance, tells us we're now taking 30 minutes longer. Let's look into the constraints. Most of them stay the same, so we still don't want to exceed the capacity. We still don't want to ship more coal than available. We still want to load everything within the turnover time, but we can increase the turnover time a little bit by delta to still be able to increase our revenue further. The second thing that we need is we also need non-negativity on delta, because otherwise, let's just say we ship nothing. Then in this constraint, the loading everything within the turnover time constraint, we would be able to set the delta to minus T, so in our case to minus 2.5 hours, and we would get actually remuneration from that. And this is, of course, nothing we want. So this is why we also have to introduce a non-negativity on our auxiliary variable. And lastly, we manipulate the objective function. So far, the objective function was just maximizing the shipment revenues. But now, of course, we want to maximize the shipment revenues minus the cost for slower turnover. Because otherwise, we would always set our delta to infinity and be done with it, which is clearly not what we want. So let's look into what these penalties can stem from. There's a lot of options where these penalties can stem from. So for instance, costs for port usage, which in our case makes a lot of sense. Then lost sales from used time, because let's just say I can go from Antwerp to Rotterdam, then back to Antwerp, and then I can go again. So of course this costs me some time. I use my barge a little bit longer. It can also be from emissions. So this doesn't really apply in our case, but in a lot of cases, penalties are actually emissions, some valuation of emissions. It can also have to do with unhappy customers. So in our case, for instance, those unhappy customers could stem from, I really wanted to have my sand delivered by 12 noon in Rotterdam, but due to the fact that they were loading a little bit longer, I'm now only getting it delivered an hour later, which is not what I wanted. This is not what I signed up on. And then, of course, also security risks. So not necessarily in the example that we've been looking at, but let's just say we're exceeding our capacity. If we're exceeding our capacity, then eventually there is a risk that our barge is no longer able to ship. The problem with these penalties is, of course, that they're difficult to quantify. If it's costs for port usage is relatively simple, we can look into how much it would cost us. But if we're talking about security risks, if we're talking about unhappy customers or even emissions, we're really having difficulties to put a proper value on them. So what I would like you to do to solidify what you've been learning about soft and hard constraints is model this. So currently we have 120 tons of coal available in Antwerp. What we now can do is we can wait a little bit, or we can buy from our competitor to increase the amount of coal that is available in Antwerp. How does this change the mathematical model and also the solution? What I would like you to take away from this web lecture on soft and hard constraints is, first of all, what a hard constraint is. Secondly, what a soft constraint is. I would also like you to take away how difficult it is to set costs for violating a soft constraint, at least in a lot of cases. And what I would like you to do is I would like you to explain the changes that we saw in the first case of should be. And secondly, I would like you to model the soft constraint on coal availability. Thanks.